You know, we build our world on machines that are supposed to last. But what happens when a threat you can't even see, a tiny microscopic crack, can bring the most powerful engine to a grinding halt? Today, we're diving into how AI is becoming our first line of defense, creating a future of, well, almost unbreakable machines.
The answer? Pretty much everything. That tiny, almost invisible flaw, that's the seed of disaster. It's the quiet beginning of a chain reaction that can lead to something truly catastrophic. And for decades, the biggest engineering puzzle has been finding that one tiny crack before its story takes a tragic turn.
Okay, so picture this. A massive industrial shaft, maybe the heart of a power plant, just spinning relentlessly under incredible pressure. All that constant stress creates something called metal fatigue, which is basically the material getting weaker from the inside out. It's what lets those tiny cracks form and grow, spreading silently until, bang, sudden catastrophic failure. And as you can guess, the consequences can be enormous.
But what if we could see the future of that crack? What if we knew where it was going? Well, that's exactly where AI is completely rewriting the rules. We're shifting from just reacting to disasters to actually predicting them with some scary good accuracy. And this is all made possible by mixing the power of AI with a field of engineering called fracture mechanics.
So, fracture mechanics. What is it? Simply put, it's the science of how things break. It gives us the physics, the rules of how cracks form, how they grow, and how they eventually cause a total failure. Think of it as the official rulebook for structural integrity, and AI has just become our master interpreter for reading it.
This slide right here really captures the whole revolution that's happening. On one side, you've got the old way, a lot of guesswork, building things way stronger than they need to be just in case, and running these super slow, super expensive simulations. But on the other side, that's the AI-powered approach. Precise, proactive, and incredibly fast. It isn't just a small improvement, it's a whole new era of what we could call failure preparedness.
So how does this prediction thing actually work? Let's walk through it. First, as you see here, the AI creates a digital twin, a perfect virtual copy of a real-world part. Then, using some really advanced simulation techniques, it applies virtual stress, basically aging the part years in just a few seconds. This lets the AI, in step 3, predict exactly where a crack will form and how it's going to grow. And finally, it spits out a clear life forecast, telling us the component's entire usable life. I mean, this is a quantum leap beyond those old, clunky methods. Okay, so predicting a crack's future. That's huge. But what about understanding the failures that have already happened? You know, a lot of the time, the most valuable clues aren't in some complex sensor data. They're hidden in plain sight, in the words of the engineers and technicians who know these machines inside and out.
Now, this maintenance note might look really simple, but it's an absolute goldmine of information. This is what we call unstructured data. It's human language, full of nuance. A veteran engineer reads this and immediately sees a massive red flag. The real challenge, and the next big breakthrough, is teaching an AI to read this note with that same expert intuition.
And this is where it gets really fascinating. Using something called natural language processing, or NLP, we can literally teach an AI to read. Simpler models work kind of like a word scanner, just counting key words like vibration or noise. But the real power comes from the more advanced models. One, like you see here, acts like a universal translator, understanding the meaning behind the words, even across different languages. Another one works like a smart filing clerk, automatically sorting through thousands of reports and grouping similar ones together. This lets the AI connect dots and find a root cause that a human might have easily missed. All right, so we can predict the future and we can decode the past. But what's the ultimate goal here? Well, it's to embed this intelligence directly into our machines, creating systems that don't just tell us about problems, but actively prevent their own failure, right there, in real time. But there's a huge bottleneck: speed. When a machine is right on the verge of a breakdown, you just don't have time to send gigabytes of data to some distant cloud server and wait for it to think. By the time the answer comes back, it could be way too late. In this world, milliseconds are everything. So the ideal delay is zero. Nothing. Instant. The solution is this incredible breakthrough called tiny machine learning, or tiny ML. Researchers have figured out how to take a powerful AI model and quantize it, basically shrinking it down so it can fit on a tiny, low-power computer chip. This chip lives on the machine itself, analyzing data instantly. There's no delay, no cloud, just immediate, on-the-spot fault detection. And when you put all these pieces together, you get this incredible, intelligent loop. It starts with smarter design, using AI to create more resilient materials right from the get-go.
Then it moves to causal analysis, where AI predicts potential failures. While the machine's running, that on-device AI provides real-time monitoring, acting like a 24/7 guardian. And finally, by analyzing all those maintenance reports, the system learns and informs the next generation of design. It's a self-improving cycle that completely transforms what reliability even means.
Look, this isn't just about keeping one factory line running. This revolution in failure prevention has huge implications for everything, from our power grids and airplanes to the bridges and tunnels we rely on every single day. It points to a future that's just plain safer, more efficient, and way, way more reliable.
So, what are the big things to take away from all this? First, AI gives us the power to predict, to see failures before they ever happen. Second, it can decode human experience to find those hidden clues. And finally, it can be embedded directly into our machines, empowering them to prevent their own failures. Predict, decode, and prevent.
And that brings us to one last really powerful question. We are on the verge of creating machines that aren't just strong, but are self-aware and resilient. So, if we can teach them to prevent their own failure, what's the next great problem we can teach them to solve? As we keep exploring these questions, the future of what's possible is literally being rewritten before our eyes. Thanks for digging into this with me.